So today we're finishing up doing section 8.5, which is properties of kites and trapezoids. These are the last two shapes we're going to talk about for the quadrilaterals. Last two shapes we're going to talk about for the quadrilaterals. They're not particularly tricky, and we're going to use that flow chart that I provided you before with all your other properties on it. So if you don't have that out, you should go get that out as well in your binder. Review real quickly. We're not going to cover. We just took a quiz on that, so I think we're good. So far, we've covered this much. We did quadrilaterals, we did parallelograms, and then underneath we had rectangles, rhombi, and squares. Okay. Now, today we're going to add the other wings. Okay. So if you look on your flow chart, you've got the two sides off to each corner. The trapezoids, and then the special type, the isosceles trapezoids, and then the kites. Okay. First thing we're going to talk about is trapezoids. So your definition of a trapezoid, you can put this in number 1. It has exactly one pair of parallel sides. Exactly one pair. Okay, that's very important. Exactly one pair of parallel sides. As opposed to a parallelogram which has two pairs. A trapezoid has one pair of parallel lines right here. We call these the bases. So this is a base, and this is also a base. Okay? Please write that down. The other two are called the legs. And we've used both these terms in different places before. Sorry, I guess that's not plural. That's just leg. So the other sides are called the legs. Okay? The non-parallel sides are the legs. The parallel sides are the bases. Notice that the bases do not have to be top and bottom. If I had a trapezoid like this, the bases would still be the parallel sides. Okay? It'd just be the ones on the left and right. So base does not necessarily mean bottom. Is that clear? Okay. We had a problem like this on your quiz. They required you to prove that it was a parallelogram, right? For this problem, it says to prove that it's a trapezoid. Okay? How many parallel lines does a trapezoid have? How many sets? Just one, right? When we did the parallelogram, and this is a mistake a lot of people made on their quiz, you needed to do 4 total things, because there were 2 sets, right? There were the lines that went this way, and then the lines that went this way. So that was 2 sets, or 4 total. Here, because it's a trapezoid, we only need to do 1 pair. Okay? Taking a look at it, and this is something Mr. Howell pointed out from, actually he was sitting in here the other day. It's not necessary for you to calculate all of them in this case. Look at RO and ST. Everybody see RO and ST? RO, ST. Are those 2 lines parallel? No. What does parallel mean? Are they ever going to intersect? These are going to intersect, right? So in this case, I would argue that you do not need to prove it. But what you need to say is you need to say by inspection, which means to look at or to examine. So by inspection, I know that RO is not parallel to ST. This is a shortcut. I'm trying to make your life easier, all right? If it's not as obvious as this one, you can't take that shortcut. So this one is pretty darn obvious that those 2 lines aren't parallel, right? Are we okay with this? Are we awake? I'm not even getting a head nod. Are we okay with this? Okay. The next thing we need to do then is compare the other two lines to prove that the other two are parallel. So we want to know, is RS parallel to TO? That's what we're looking for, okay? How can we compare to see if they're parallel? We need to check the what, Ted? Not the x-axis. What do we do on the quiz when we got this problem? We found the slope. And what was true if the slopes were equal? They're not congruent, they are parallel. Okay, because look at these two. This one is much shorter than the other one. So parallel, just to refresh your memory, parallel is the same slope. Congruent is the same distance. So we want to prove that they're parallel here, so we need to find the slope. What is my slope formula? Raise your hands, please. Otherwise, everybody can shout out. Slope formula. Huh? y2 minus y1 over x2 minus x1. So a few hints from what I graded on your quiz. A lot of people did not list which one it was. So if you're going to do RS, let me know that you're doing RS by labeling it. A lot of people just threw some numbers out there. Yes, I can figure it out, but assume that I don't know what you're doing. Okay? So RS, let's label them, x1, y1, x2, y2. So when I plug it in, it becomes y2, which is 4, minus 3, over 2 minus 0. 4 minus 3 is 1, 2 minus 0 is 2, so I get 1/2. Is that okay with everybody? Then I want to compare TO. Okay? Label them again. x1, y1, x2, y2. So y2 is 2 minus 0 over 4 minus 0, which gives me 2 over 4, but can I reduce that? What's 2/4? 1/2. What can I conclude here? They're parallel. Can I make another comment about what I got on the quiz? A lot of people would give me just this. So this is gone, and they give me just the half. So I was very lenient when I graded the quiz. However, on the test, what you need to tell me is something like same slope, so, and then you can say that these two will be parallel. Okay? I did not take off points on your quiz. I was very generous. However, on your test, I will. Okay? Because you can't just stop at a number. I didn't ask what is the slope. I asked, are they parallel? Can you prove it's a trapezoid? So even more, I might even say, you know what? These have the same slope, so therefore they're parallel. And I know these two aren't parallel, the green lines, right? So therefore, my definition was exactly one pair. And if you look at back to my picture, green is not parallel, red is parallel, therefore it's exactly one pair, so it must be a trapezoid. That would be a phenomenal answer, okay? So a lot of people did the math correctly, but then you just need just a quick little 4 or 5 words to say why you did that, okay? Does that make sense? Questions before I move on? So there'll be a few of these on your homework, okay? And there'll be one like this on your test. An isosceles trapezoid, which is right down below. This is a definition, so it's not going to go it's not going to go on your property sheet, so you're going to have to write it off to the side. But the isosceles trapezoid, the legs are congruent. The legs are congruent. So that means you have your trapezoid. What are these lines called? The what? bases, because they're parallel. The legs now are these guys, and the legs have to be congruent. Leg, leg. Okay? So the isosceles trapezoid is still a trapezoid. There's only one set of parallel lines, and it's the bases. But now we know that the legs are congruent. Okay? It's a special type. Just like a carrier is a special type of dog. Okay, we're getting more specific. Make sense? Okay. Correct. In fact, they can't be parallel because the trapezoid can only have one set. Make sense? The two properties that should go underneath there for 1 and 2. I'll draw pictures after you write these down. So number 1, both pairs of base angles are congruent. Both pairs of base angles are congruent. And then number 2 is the diagonals are congruent. The diagonals are congruent. Both pairs of base angles are congruent, and then the diagonals are congruent. So the base angles. If I draw an isosceles trapezoid, here's my legs. What are these called? Bases, and they are parallel. When it says both pairs of base angles, hopefully you can see it. If I name this A, B, C, D, give me a pair of angles that are congruent. Which two angles would look congruent from this picture? A and what? And D. Do you notice that they're both acute? So A and D are congruent. They're called base angles because notice how they both touch the same base. See how they're both on the bottom here? And then there says both pairs. So where's the other pair? So BA and CD is the line. We already marked that. I want the angles. B and C. So angle B and angle C. And those look congruent. You notice how they both have 2's? Is this okay? And that's true for any isosceles trapezoid, any isosceles trapezoid. The diagonals are congruent. Draw another one. The bases are parallel. The legs are congruent because it's isosceles. Isosceles, remember, meant 2 equal sides from triangles. Remember when we covered isosceles triangles? The same sort of thing here. The diagonals are congruent, so if I name this ABCD again, I know that the diagonal BD must be congruent to the diagonal CA. So BD will be congruent to CA. Okay? BD is congruent to CA. Do those diagonals bisect each other? Bisect means to cut into 2 equal pieces. Do these cut each other into two equal pieces? No. If you look at your property sheet, that was one of our properties for parallelograms. So parallelograms have that under here. But remember we talked about the trickle-down effect, right? It would trickle down underneath it, but it couldn't go up and around. Okay, so totally different properties over here. Correct. So the only 2 properties are right there. Okay. Now we need to add some numbers. Okay. So find all the missing angles. First up, what is that shape called? What is that shape called? Trapezoid. Can you be more specific? Isosceles trapezoid. Notice that it is rotated. Okay. Which 2 are my bases? Raise your hands, please. Julio? KJ and LM. It doesn't matter if the base isn't on the bottom at this point. What are my legs? What are my legs? Devin? JM and KL, okay? So, any thoughts on how I could do this one? Any thoughts on how I could do this one? Clear?
There's 180 on K.
Say that again?
There's K 180.
118.
Oh.
So look at your properties we just went over. We had one property about diagonals. Is that going to help us here? Diagonals? I disagree. What's the other property now? It's about what? Both pairs of base angles are congruent. Well, what's my base angle with K? Which one's going to be congruent to K? J. So J has to be how much then? 118. Okay? And what do we know about M and L? Oh, I just showed you. Whoops. What do we know about M and L? What does the symbol mean? They're congruent. Do you see how the base angles are here and here? Just like we did the picture from the last slide. Notice the base angles BC and AD. Same process, except now it's just rotated. KJ and LM. Is everybody okay with that? So we need to set up an equation. How many degrees are there total in a quadrilateral? 360. So 360 degrees is going to be equal to, let's walk around the quadrilateral. We have 118 plus 118 plus, what should I call the other ones? X. If angle M is going to be X, what's angle L going to be? X, because they have to be equal, right? Does this make sense? We did this in chapter 1. You find the total, and then you add up all the inside angles. Set them equal? Yes? No? What's going on today, guys? Did you go to sleep last night? Okay. How can I solve this? 360, add up the x's. Can I combine these two? What's that going to give me? 236. 236 plus how many x's? 2x. Next step. Minus 236. Minus 236. What will that give me? 124. 124 equals 2x. Last step, divide by 2. Just 2, not 2x. These will cancel, the 2's. We get x is equal to 62. Okay? Does that seem like a reasonable answer? Why? No, that's not a terrible reason. You're assuming that that's correct. You said, I just asked, does that seem like a good answer? You said, yes, because that's the answer. Does that make sense? No, it's not just you, but that's what I get a lot from students. I'll be like, is that right? And they're like, yeah, because that's what I got. How could I check it? What's a good reason why that seems appropriate? Put in x. So if this is 62, just from a simple check, the green angle has to be acute or obtuse? And 62 degrees acute? Yes. A lot of students will forget the second x, and they get the answer as 124. Always take a look at your picture. 124 would not work there. Okay? Does that make sense, Maya? Mm-hmm. So it's a way to look at some outside information to verify. Okay? Oops. All right, we need to talk about the midsegment. The midsegment of a trapezoid. We talked about this. You don't need to write this down real quick. But we talked about for triangles. Do you remember when we connected the midpoints like that? And then we could do 3 of them like this? So we had shapes that looked like that. Do you guys remember that? And we knew that the mid-segment was parallel to this side, and it was half the size. Do you remember this? Okay. We have the same sort of thing for the trapezoid. It's just a one small step different. So the mid-segment of a trapezoid is once again parallel to each base, and its length is 1/2 the sum of the bases. Okay? Half the sum of the bases. This is for any trapezoid. It doesn't have to be isosceles. Khalil, wake up. Let him go. Nothing. We got a test on Monday, and this is the last thing we're covering. So. So if you form any trapezoid, we'll name it ABCD. The mid-segment connects the 2 midpoints. Remember that the bases here, BC and AD, are parallel. So the mid-segment will connect the 2 midpoints, which are right in the middle, BA and CD. It will connect them. Whoops. Connect your midpoints. Notice that it is parallel to both of the bases. Do you guys agree with that? And it's going to be half the sum of the bases. So let's name this XY. And write an equation for this picture. Write an equation for this picture. So, the mid-segment, what's my mid-segment? XY. The mid-segment is equal to half. How do I write that? Half the sum of the bases. What are the bases? Careful. BC and AD, and what does sum mean? Plus. So literally this says the mid-segment is equal to half the sum of the bases. Okay? Does that make sense how we got that right from our words? Mid-segment is equal to half the sum of the bases. There will definitely be problems like this in your test, okay? Definitely be problems on this. So here's the problem. Find Mn. So find Mn. So I'm going to say the words. I want you guys to tell me what to write. The mid-segment is equal to half the sum of the bases. PQ plus SR. Very good. So all you got to do, and then just plug and chug. Do we know what Mn is? No, so you can leave it as Mn, or you could put an X on it. Doesn't matter. What would you guys like? X. So X equals half. PQ is what? 12 plus S is 28. You guys can solve that, I hope. So X equals half. Do your parentheses first. What's 12 plus 28? 40. And then what's half of 40? 20. So X equals 20. 20 what? Inches. Very good. Okay, notice that it has to be 20 inches. Okay, I want to show you a shortcut. Yes? Okay. I want to show you a shortcut. What's that on this page? This will always work, the equation we've written. A shortcut that could be helpful If you don't like it, then you don't need to use it. How do I get from 28 to 20? Subtract what? 8. Everybody see that? How do I get from 20 to 12? It's from 20 to 12? Subtract 8. Whenever we get these problems, the mid-segment is exactly in the middle, okay? The mid-segment's in the middle. It's like a belt around it, okay? So notice that whatever we do to get to the mid-segment, we would also have to do to get to PQ. Does that make sense? So that's a way to check your work. These two numbers should be the same. All right? Those two numbers should be the same. I'll leave it up there for a second so you guys can write it down. It depends on which way you look at it, Luis. If we start on the top, you do 12 to 20. That would be plus 8. And then 20 to 28 would be plus 8. It just matters which way you go. Okay? And it doesn't have to be 8. It could be anything. But the two numbers have to be the same. It could be plus 6, or minus 6, minus 6. Okay? Now a harder version, because we throw in some x. Right? Throw in an x, becomes a little bit harder. So I'm going to say the words, you tell me what I need to write. The mid-segment. 12.5, very good. The mid-segment is equal to half the sum of the bases. 3x plus 1 plus 15, good. You see how we combine the two different bases there? Okay. Now we can clean up this parentheses a little bit. So we're going to get 12.5 equals half times 3x plus 16. Now, at this point, the half is a little tricky to deal with. You could distribute the half into your parentheses using the distributive property, but then you're going to end up with 3 halves x, and it's going to get a little nasty, okay? What I might suggest at this point, a half. What does the fraction bar mean? What does the fraction bar mean? So I have to say 1 over 2. It's 1 what? 2? Divided by. Okay? Divided by 2. So this really means, half means we just cut it in 2, right? Divide by 2. So if I say what's half of 40, like we did on this problem, you just divide it by 2, right? Does that make sense? If I want to get rid of something in algebra, I have to do it to both sides, right? But I have to do the opposite. If I want to get rid of divided by 2, what would I have to multiply? Sorry. What do I have to do to both sides? Multiply by 2. Does that make sense, how the inverse is? Yes? No? This is really important. Seriously, some feedback would be nice here. Okay. I'm just going to keep going. So if I want to get rid of the half, I need to multiply by 2. And whatever you do to one side, you have to do to the other side. Okay? Does this make sense that we're doing the opposite here? So what's going to happen is that your 2 will cancel out completely with the half. Julio?
But if there's 1 half times the number that but you have to do the division.
Correct. So you could. What we're doing is we're avoiding that step. So Julio asked, do you have to distribute this because it's next to it? Well, technically, yes. But if we're going to multiply by both sides, we're going to distribute a divided 2 into both, and then you distribute a times 2 into both. So those are all going to cancel out at the end. Okay, so we're just doing it before that, so it's going to be less work for us. Okay? What is 12.5 times 2? 25 equals, and then look how easy the other side became. What do we get left? 3x plus 16. Nice? You can solve that, right? What's my next step? Subtract 16. 9 equals 3x. So therefore x equals 3. Okay? Any questions on that? X equals 3. Let me show you how we could do that using the shortcut. On the last page, I told you about the shortcut. Okay? I go from 15 to 12.5. How did I move there? What do I subtract? Minus what to get to 12.5?
2.5.
2.5? So what would I need to subtract to get to this one? What is it? 2.5? So minus 2.5 again. So what's that going to leave me at my top? 12.5 minus 2.5 would give me 10. So all of a sudden I know that the top has to be 3x plus 1. I also know it has to be 10, right? So I could say that 3x plus 1 equals 10. You subtract 1 from both sides, you get 3x equals 9, and that's right what we had before. So you get x equals 3. So that shortcut might be helpful here. It saves us a couple steps. Whichever way you want to view it is fine. The shortcut won't always work. Let's say that there was an x right here. Instead of 12.5, this is like a 5x minus 7 or something like that. All of a sudden it becomes a lot more tricky. Any questions on this problem? Any questions? Okay, we need to talk about a kite. Kite. The definition of a kite, don't put this in one of those spots on your paper. This is just the definition. It's got two properties coming. This is the last shape we're talking about. Last shape we're going to talk about. The kite is defined as two pairs of consecutive congruent sides, but opposite sides are not congruent, which is kind of a mouthful. There's not really a very pretty definition, but when you see it, you know it. Kites, for the first time, geometry people made sense. They named it a kite because it looks like a kite. Okay? Makes sense, right? You notice I gave you one of these on your Venn diagram right here in the corner. Okay? It has two pairs of consecutive, which means next to each other, congruent sides. Those two pairs are right there. And there's one pair, the other pair is in green. Okay? You notice how it looks like a kite? Like an old school kite. Mary Poppins style. Are we okay with this? The two properties we have for kites. The diagonals are perpendicular. Diagonals are perpendicular. I'll draw a picture in a second. And exactly one pair of opposite angles are congruent. Exactly one pair of opposite angles are congruent. So I've drawn two kites. I know that these two are congruent, and I know that these two are congruent. The diagonals are perpendicular. Diagonals cut across. There's one diagonal. There's the other diagonal. You see how it forms a nice cross in the middle? And there's my right angle. So those are perpendicular. We're going to use that property in 1 minute. Okay? So hang on to that for a second. The diagonals are perpendicular. The other one is that exactly one pair of opposite angles are congruent. Those opposite angles are the ones that show up in between the two that aren't equal. So they're across from each other on the kite, and they're in between the two that are not congruent. Questions? Find all the missing angles. So first off, notice this is still a kite. It's just really ugly looking one, right? It's fat. Okay? See how it's been pulled out to the sides? What do we know about, well, you guys tell me. What can we do here? We want to find all the missing angles. So which one do we need to find? E and G, right? Henry? Okay, H is right, so H is 90 degrees. Okay. Okay, and what's that going to give me? Perfect. That is correct. I'm going to do it a bit more formalized, using some x's and equations, but that would give you the correct answer. Henry, what do we know about angle E and angle G? They're congruent. These two are congruent. So Henry, if E, which is our unknown, is x, what does G have to be? X. Okay? Now this should look a lot like the problem we did right there. How many degrees are there total in any quadrilateral? And do we know all of the inside angles here? We have values for them? Well, we have x. So can we plug it in? So we just say that 360 is equal to 150 plus 90 plus x plus x. You can say 2x, not x squared, though. X squared is x times x. Sure. So 360 equals, what's 150 plus 90? 240 plus 2x. We subtract 240 from both sides. We get 120 equals 2x. Last step is to divide by 2. Then we get x equals, whoops, 60. Sorry. And since x is an angle, it should really be 60 degrees. Okay. Any questions on how I did that? Remember, how many degrees total for any quadrilateral? 360. Okay, that's going to be very helpful. Questions, comments, concerns? All right, the last problem for today, and then I want to talk about your quizzes. Last problem for today. Find the perimeter of the kite. This is a hard one. What does the perimeter mean? All of them, all the sides, so everything on that picture, or can you be more specific? That's a Y. So yes, it's the distance around the figure, so it doesn't include anything inside. Right now, have I given you any of those distances on the outside? No. Any thoughts on this one? We do have to use the middle stuff. Any other thoughts? I told you to hang on to one of those properties for a little bit. Which property was that? No, like from today. Diagonals are, so are those, what are those light blue lines? Are those diagonals? And what do we know about them? They're perpendicular, so they hit it at a what type of angle? Right angle. Everybody see that? Does that help at all? Why? Does that help at all? You do this?
Yeah.
Oh. Why?
Because you have an angle, right?
Yep.
And then that equals 90, and then you have the base of the angle, 19.
Mm-hmm.
Then you have the height,
Mm-hmm.
10.
Mm-hmm.
And yeah, that's why I see the triangle.
However, what you're looking for, I think, is to find the area, right? You're talking about the base and the height. We don't need the area. We want the perimeter. So really what I'm looking for is this line right there, because I want to know what WX is, right? I like that you pointed out the 19 and the 10. Anybody see it? We'll see it in 1 second if I draw the line, but I want to see if anybody gets it. Turn it into a what? Triangle. What's that called? The something theorem. Pythagorean theorem. Notice I'm going to redraw this triangle. I have a 19, a 10, and an X. Everybody see that? Which one's my A value? Does it matter? Which one's my C value? It does matter. It has to be the hypotenuse. Sorry. Hypotenuse, which has to be what here? X. So we can say A squared plus B squared equals C squared. Make sense? We don't have calculators today, but I'll give you some. So A squared doesn't, I'll just say 10. So 10 squared plus 19 squared equals C squared. What's 10 squared? 100. Plus, anybody know 19 squared? 361 equals C squared. And then we just add those two together. 100 plus 361 is 461 equals C squared. What's my last step? Square root. So C equals the square root of 461. Does that make sense how we did that one? Now, if you had a calculator, you could type that in and get a decimal, right? Does that make sense? If you had a calculator, you could type it in and get a decimal. So this one is square root of 461. We'll take a look at WZ. WZ is 19 and 10 again, right? Is WZ going to be the same thing? Remember, because kites have, this piece can be equal to this one, right? So this one also has to be square root of 461. And then we have another small triangle right there. Does everybody see that one? Everybody see it? So if I draw that little guy, I have 5, 10, and X. What do you mean with 3 triangles? Oh, you're thinking of similar right triangles when we had to redraw them? We don't know that here because we don't know that that's a right angle. We don't know. It could be, but we don't know. It hasn't given to us. Okay? A squared plus B squared equals C squared. So 5 squared plus 10 squared equals X squared. Sorry, I probably should have plugged in an X there.
Can we do what you said because we have the value X and Y for that one time?
Correct, but we don't know the angle X is 90 degrees. Remember, we had to have 3 right angles. We have these 2, and then we always had to have the one at angle X. It could be, it looks like it might be, but we don't know for sure. Does that answer your question? So 5 squared plus 10 squared equals X squared. So 25 plus 100 is equal to X squared. That gives you 125 is X squared. Last step. X equals the square root of 125. Thank you, Jasmine. if we draw this on our picture, square root of 125, what does y z have to be then? The same thing, because they're congruent. So y z will also be the square root of 125. The perimeter then, what do we do for the perimeter? Okay? Correct. So you plug them in the calculator, get the decimal form, add them all together, you're done. Okay? Remind me, I'll tell you something after class, okay? Real quick. Your homework for tonight. All those problems. This is the last assignment for the test. Okay? What is that? Anybody know? Yeah, this was when I was thinking of putting a test on there or something that might have gone away since you guys were unborn. But apparently you still know what it is. Give it 3 years and I think people won't know what it is. Alright? So your homework, these first two are graphing trapezoids. Then there's a few mid-segment problems. Then there's a few kite angles and trapezoid angles. And then the last few are kites using the perimeter. Okay? Guys, I really encourage you, please use your notes for tonight's homework. After school today, the Georgetown tutors are here. I will be here. At 4:30, a reminder, Mr. Howell is showing Moneyball in here, if you're interested in staying and watching it. Your test is on Monday. On Friday, we will be reviewing, okay? I have your quizzes to pass out. Let me stop the recording. Sorry, I'll bring it back up.